Welcome to task 1.1. We're actually not going to start on page 1, and we're going to skip over page 2, and we're going to go to page 3, not at the very top, but where it starts with arithmetic sequence. And we're going to fill in that table. So a pattern in arithmetic sequence is where we're going to start, right here. An arithmetic sequence has an adding or subtracting pattern. Those are the two blanks. So in the column on the right, it says, is growing dots or growing dots arithmetic? So go to page 1 in your packet, and that is what we call growing dots right here. And let's take a look at that pattern. It says at the beginning, we have 1 dot. At 1 minute, looks like we have 5 dots. And at 2 minutes, that looks to be 9 dots. So the pattern that I see here going from 1 to 5 and then again from 5 to 9 is adding 4. So that's what we would call the pattern in growing dots. Now if you go to page 2 in your packet, that is called growing dots, and let's look at that pattern. In the picture labeled 1 minute, we have 3 dots. In the picture labeled 2 minutes, we have 6 dots. The next picture, 3 minutes, looks to be 12 dots. 4 minutes is 24 dots. And 5 minutes, if you count all those up, it looks like that's 48 dots. So what is the pattern in growing dots? It appears to be from 3 to 6, and then 6 to 12, and then 12 to 24, and then 24 to 48. It's doubling. The pattern is multiplying by 2. So if you go back to page 3, an arithmetic sequence has an adding or subtracting pattern. So the one that had an adding or subtracting pattern was the first one, called growing dots. And we would explain by saying the pattern adds 4 each time. That's what we identified as the pattern. Now the starting number. We will define the starting number is how the first picture is labeled. So go back to page 1, growing dots. The first picture that only had 1 dot is labeled at the beginning. So we can go ahead and label the starting term number at the beginning. However, it says the starting term number. So the number at the beginning is the number 0. And we do have labels in this case. They were identified as minutes at the beginning, then 1 minute, then 2 minutes. So I'm going to go ahead and label the starting term number as minutes. The starting value. The starting value in an arithmetic sequence is going to be defined as how many items are in the first picture. So how many items, in this case, dots? Well, let's go back to page 1. How many dots were in the first picture? We counted that there was 1 dot in the first picture. So that's going to be called the starting value. And I'm just going to say it's 1. And since I have the units, I will label it 1 dot. And the last term in arithmetic sequence is the common difference. That's going to be the number being added or subtracted each time. So I will let you know that the number being added or subtracted each time could be a positive number. And positive numbers mean addition. Or they could be a negative number. And negative numbers will mean subtraction. So the common difference is the number being added or subtracted each time. It's very similar to the pattern except it's going to be more specific. So we said this pattern on page 1 was adding 4 each time. So I'm going to call that now on page 3 the common difference. Adding 4 is a positive 4. Now please turn the page and go to page 4 in your packet. This is called a geometric sequence. It is very similar when we're talking about most things. The pattern in a geometric sequence has multiplying or dividing as its pattern. So a geometric sequence has a multiplying or dividing pattern. So is growing dots or growing dots geometric and explain? Well, we already said page 1, growing dots, was arithmetic. So go to page 2, growing dots, and that is geometric because if we take a look, the pattern is 2. Oops, I erased it accidentally. So we know specifically that the pattern is multiplying by 2, but that is a multiplication or division pattern. So going back to page 4, I will say that this is in fact growing dots. That's geometric. And my explanation will be the pattern is multiplying by 2 each time. Now the starting term number in a geometric sequence is the same as it was for an arithmetic sequence. So the starting term number is how the first picture is labeled. So go back to your growing dots on page 2. How was the first term labeled? It looks like the first term was labeled as 1 minute. So go back to page 4. My starting term number is 1 minute, and I'm going to use the actual units of minutes. So 1 minute can be a number, which is 1. Now the starting value in a geometric sequence is the same as an arithmetic sequence. How many items are in the first picture? So go back to page 2, growing dots. How many items were in the first picture? It looks like we said that there were 3. So going back to page 4 in my table, I would say the starting value is 3 items, and our items were labeled as dots. The common ratio is what we call a geometric sequence, not common difference. That was the above arithmetic sequence on page 3. Is the number being multiplied or divided each time. So again, you can think of it as the pattern, like we did with the arithmetic sequence, but we want to know the actual value. So go to page 2, and what was the pattern again? It was specifically multiplying by 2 or doubling. So I'm going to say the common ratio is times 2, but I'm going to write it as 2 over 1 because a ratio is a fraction. So 2 is the same thing as 2 over 1. So on page 5 in your packet, we have a practice pattern. So it shows you 4 figures, figure 1, figure 2, figure 3, figure 4, and it says draw figure 4 here. We actually mean draw figure 5 here. So I'm going to try and figure out what in the world the pattern even is. It looks to me like we've got an L right here. It's here originally, here originally, here originally. And then it looks like we just add another L onto it each time. But that's really hard for me to see, so I'm going to highlight. The first L is going to be in yellow. So I'll draw that. Might as well draw it on the next figure. The next L I'm going to draw in purple. There it is right there right there, right there. I'll draw it right here. The next L, let's make it red. Here it is right here, right there, right there. And the next L, let's go for black. Who doesn't like that? It's right there and right there. And then I've got to add one more L. Let's make it blue. And it would be right here in the last figure. So each L has 3 boxes. So I had 3 squares or boxes, then I had 6, then I had 9, and you can count them individually if you'd like. Then I had 12. Here I should have 15. So if this is 3, and this is 3, and this is 3, and this is 3, and this is 3, I think in fact I do have 15. If you felt better actually drawing the boxes and seeing them specifically, you can do that. It's totally up to you. Neither way is wrong. They are both correct. So there is figure 5. So now we want to know the starting term. Now remember, the starting term number is how the first picture is labeled. My first picture is labeled as 1. So the starting term number is 1. The starting value, remember the starting value from the previous pages is how many items are in the first picture. How many items are in the first picture? I counted 3. And what were each item? They were squares. So I'm going to label it 3 squares since I have that information. Now the pattern. My pattern I haven't labeled yet, but I went from 3 to 6, from 6 to 9, from 9 to 12, from 12 to 15. Isn't my pattern addition of 3 each time? So I would say my pattern is you start with the L. So I guess I should say start with the 3 boxes. I'll just draw them. And then what I'm going to do is add 3 each time. So this is an addition pattern. So that's arithmetic, not geometric, because the pattern is adding. And now I know an arithmetic sequence has a common difference, so I'll circle it, not a common ratio. And we said that that common difference was up here plus 3. So my common difference is plus 3. And I'm done with number 1. Number 2, it shows you 3 figures. It wants you to draw the next one, but the figures are called 0, then 1, then 2, then 3. So it looks like, I'll change colors here to be more obvious. We have 1 circle, then 2 circles, then 4 circles. I'm seeing a pattern here from 1 to 2 and then 2 to 4 of doubling or multiplying by 2. So if I double again, I should get 8 circles. So I will draw 8 circles for the next figure. And my starting term number, remember, my starting term number was how the first picture is labeled. The first picture is labeled as 0 in this case. The starting value from the previous pages was how many items are in the first picture. Well, we said there was 1 circle in the first picture, so I am going to label it since I know the units. Describing the pattern, I would say we start with 1 circle and we multiply by 2 each time. So if I'm multiplying, this is a geometric sequence because the pattern is multiplying. And a geometric sequence had a common ratio. So what exactly was that pattern? Well, if you take a look, specifically, I was multiplying by 2. So I will say that this pattern is called a common ratio, would be times 2. And remember, we were going to write that as a fraction, so times 2 over 1. So thank you very much for watching the video. You can always go back and fill in some of the other questions on pages 1, 2, and 3 that you missed.